Okay, for your minerals lab, I'm going to try and help you use some of the physical properties to identify a variety of minerals. So hopefully by this time you've watched your video, you've looked at your lecture material, and you've read the Lab 3 activity for minerals. Now in the Lab 3 activity, it talks about the different physical properties that we use to identify. Scale is based on your fingernail, a copper penny, a steel nail, and a glass plate. We will use these to determine the hardness of some minerals. You also see that streak, which is scratching a mineral on a white porcelain plate or even a black porcelain plate. So we'll use that. We'll do some streak. We'll try out reaction to acid and reaction to magnets. And we will also look at the color cleavage, which is the mineral breaking in a plane of weak bonding. And if you watch the video, you kind of understand what that is. Color that much because color can vary. If a mineral, for example, quartz, quartz has many different colors that it can come in, and the mineral always is made of the same materials as you saw in the original video. It's always made of the same elements, but sometimes an element can get thrown in there in the combination and inside the matrix and cause the mineral to be a different color. So we don't consider that a real accurate one. But streak, even though the mineral could be a different color, its streak will always be the same color. So let's go ahead. Now luster is defined as the reflection of light off the mineral surface. And we're going to stay simple for this exercise. There's metallic and a non-metallic. That's the largest breakdown of luster. And then there's many other kinds underneath that. But we're going to break our minerals down by metallic luster first and non-metallic luster so that we can start to separate them out and start to identify them a little more easily. Now metallic luster is kind of like the shine that you see on a penny or the shine on a piece of metal. It's the way the light reflects off of it, and we're going to call that metallic. So we're going to review our minerals here and see if we see any that appear to have that kind of a shine. Now, a non-metallic luster may appear shiny, so don't mistake that for a metallic shine. Think about metals. Plastics will shine, glasses will shine, and they look very glossy, but they don't have that metallic property. So are you seeing any that look metallic to you? And sometimes metallic is even just flecks and flakes. So if you think about the paint on a car, it can look like it's got little flecks of metal in it, and that can be considered a metallic property as well. So out of all of these, hopefully you've selected this one, and a little more difficult, especially between these two and probably on a video camera, but this one. This one you can kind of see a metallic shine on it. So we're going to call that one metallic as well. So now we've got them separated out into our metallic and our non-metallic minerals. Now, if you'll take out the sheet that you've been provided, you have a matrix that's completely filled in with all the properties and the lusters and the hardness for the minerals. And then you have a blank table that you need to fill out for your assignment. So let's go ahead and head to the blank sheet that you need to fill out for your assignment. So now that we have our three metallics, we need to figure out which one is which. So let's go ahead and see that first line says metallic. It's got a streak that's greenish black. Alright, well we know that a streak is when you drag the mineral across the porcelain plate. So let's go ahead and see what this one has. That's a pretty dark streak. I would say that that's black to gray. That one's got a real dark streak too. That's probably a black. Oh, let me do that one again. Can you see the green in that? It looks a little more green than it does black, doesn't it? So let's go ahead and say that this one has kind of a greenish black streak. let's look at our table that was actually filled out and see if we can find one that has that. So yeah, on your table, on page 2, I see one that says it's pale brass yellow in color, which yeah, kind of is, right? And it's got a greenish black streak. And it generally forms cubes, or 12-sided crystals. Can you see cubes in there? I can. So I think what we've got here, if you look over to the mineral name, what we have here is pyrite. It also says in the other properties, it's been described or called fool's gold. I would call that fool's gold. If I didn't know, I might mistake that for a piece of gold. So go ahead and fill that out up on your mineral data table. So we used property 1 to identify pyrite as the mineral name. Now let's go ahead and fill out a couple other properties that we used. Well, let's see. We used the color this time, right? Because we looked at the pale brass yellow. And we used the cubes. So maybe in property 3, I would put down that you could see cubes inside the crystal, or as the crystal form, cubes. Alright, so we've got that one done. That leaves us 2 more. Now, it says you're given the color black in number 2. So out of these 2, which one looks more black to you? Probably this one, right? So let's see. We know that this one had a streak that was really dark, right? Very black streak. So we use the color of the mineral itself, black. Let's look and see if we can find a black mineral with a black streak on our table. Did you find it? Well, I'll give you a hint. It's still on page 2. Now it says we've got a color of black mineral and a streak that is black. And in the other properties column it says strongly magnetic. It also says has 8-sided crystals. I don't know about you, but I can't really see 8-sided crystals, which means these crystals may be very small. Well, either that or this was a large chunk of a larger crystal. So we can't tell that, but we've got another property that says strongly magnetic. So let's see, will the magnet actually stick to it? Look at that. Doesn't stick to that one. Doesn't stick to that one. Sticks to that one. So yeah, that's our magnetite. So go ahead and fill out the other 2 properties that we used, the mineral name, and then find one of the common uses. You can either use that, get that out of the other properties, or you can look online. Moving along. So we've got 2 of our metallic minerals already identified and named. So that just leaves us 1 more, right? So it says we've got a cleavage that is cubic. Now, that means it forms in the shape of a cube. Looks like a cube to me, a lot like a cube, right? And if we were to take this and hit it with a hammer, it would actually break into pieces that were cubes. So I'm thinking that's it. But let's go ahead and check out some other stuff because we've got to have at least 2 more properties we use to identify it. So, our cleavage is cubic. Our color is dark gray to light gray. Yeah, I'd say that's a dark to a light gray. It forms cubic crystals. It's a principal ore of lead. Well, when we streaked it, we got like a grayish black color, right? And lead would have a grayish black color. Also, if you were here with me, you could use something called specific gravity. And that's the density of the material versus the density of generally water. If you could feel this in relation to any one of these other minerals, it's pretty darn heavy. It just feels very weighted in my hand. So let's see, what specific gravity would it have if it was pretty high? Well, it would be the higher numbers, right? So on your sheet, if you look at the third line, 7.5 is a specific gravity of this. So you can imagine this is pretty heavy even in relation to the other two metallics that we've done. So, write down, again, two properties, the mineral name, which is galena, and then one of the common uses for this. So now we're going to move on to our other minerals that are all non-metallic. So, first of all, I think I would start out by separating them into light and dark colors. So you can kind of try and break it down a little and not find it to be so overwhelming. So let's go ahead and do that first. Well, this one looks pretty light to me, so I'll put that over here. This is really light. That one's pretty light. These are almost clear, so we'll consider those light. This one's pretty light. Again, almost clear. These two are dark. This one's dark. These two are iffy. Are we going to call those dark or light? I don't know. We'll have to see. And this one also appears to be kind of light, right? So those are our lights. These are our darks. So let's go ahead and start with our lights. So on your sheet, we'll go back to that again. For your non-metallics, do we have any one of these that looks like it's got granule crystals? Granular would be kind of like sand looking. So let's see if we can get a kind of a close-up of that. Feels rough to the touch. That one just looks pretty shiny. That's shiny, that's shiny. That one's, yeah, see, this has lines in it, so you don't see the little grains. That one's pretty shiny. This one's real shiny. I see lines in this one, but no grains really. This one's very shiny. So out of the rest of these, I don't really see any that look like they have grains or are granular. But this one kind of feels like sandpaper. Kind of has an interesting green olive kind of color to it. So let's see. If we've got something that is granular crystals, we'll have to go back to our main table. Can you find something on there that has granule crystals? Read through your other properties and see. And you can also read through your color column and see if there's anything in there that kind of looks like this. We can also check the hardness, right? So let's use our Mohs hardness scale. And that can be found on the first page of your lab. Hope you have an easier time finding your first page than I am. Alright, so let's see what we got with Mohs hardness here. A 1 is that your fingernail can scratch it easily, and a 2 is that my fingernail can scratch it. So let's see. Is my finger... No, it's filing off my fingernail pretty much. I don't think my fingernail's scratching this. So we know it's not a 1 or a 2. But it makes a pretty good nail file. Alright, so let's move along. A 3 means that a copper penny scratches it. So let's see, can the copper penny get it? Looks like it might have got it a little bit. Made a little powder there. Not a lot though. So, and it looks like it's even flaking off a little bit of the copper. So it's got to be a little bit more than a 3 because it's getting some of the copper off of the penny. So let's see what we've got over here. Looking back at your sheet, can you find anything that has this color, is a little bit harder than a copper penny, which is a 3, and has a granular texture? Go ahead and try and find that on your sheet and fill out your table with the properties that you've used to help identify what this is. Make sure you fill in the mineral name and, again, a common use, whether it's off the table that's been provided for you or off of the internet. Alright, moving on to the next one. It says it's got needle-like crystals. There's your one property hint. Well, and it also says it's non-metallic, but it's darker. So we've only got the 3 in the darker so far, right? So let's look. Does that look needle-like to you? Not so much to me. So we're going to say there's no needles in that one. How about this one? Does it look kind of needly? I can definitely see some lines this way. Oh, by the way, if you see numbers on them, don't pay any attention to those. Those are not anything to relate to this course. And how about this one? Boy, those two are kind of rough. They both kind of look like they've got some needle-like or striations, lines running through them, right? So we're going to have to try and figure out a couple other properties to help us determine which one's which of these two. So let's see. Let's try some hardness testing on this one. Back to our Mohs hardness scale. Alright. Well, I'll try my fingernail on it. Well, again, I think it's filing my fingernail. So that's not, it's not getting, it's not coming off so easily with my fingernail, but it does look like I got a little scratch on it this way. So maybe fingernail, maybe a 2, but across this way, it's filing my fingernail. So we're going to stick with maybe a 2. Let's try the penny and see if the penny easily scratches it, right? Because if the penny easily scratches it, then we know it's a little bit more than a 2 or just slightly above a 2 or a 2 or above. So let's see, does the penny get it? Oh, the penny dug right into it. Look at that. Alright, so somewhere between a 2 and a 3, that one lies. What about you? Can I scratch it with my fingernail? Not at all. It's just flattening out my fingernail even more. Alright, so let's see what happens here. Well, that's not helping a lot then, is it? So they're both about the same in the hardness. This one, though, this one I got a pretty good fingernail scratch on, so maybe a little less hard than this other one. So, let's see. Do we have a non-metallic that's kind of shiny and dark? What about streak? Let's try to use streak. So I'll flip this over and we'll get on the side that doesn't have any streak on it. We'll see if we can find a difference in the streak between these two. Boy, that one's having a hard time streaking at all. There's a little bit of a grayish, greenish kind of streak on there. Just a little. Oh goodness. That one breaks off when we streak it. It's got a much darker streak to it, I think. So let's see, is there anything that's kind of black? What else have we got to help us? Well, this one barely, it barely had a streak at all, right? Oh, that didn't even streak at all. So maybe we've got one that has none. Is there something with no streak? Well, we've got a couple on there that say no streak. Is there any that kind of matches the description of this? It's kind of a greenish black color. I would say maybe a little more green than black. So go ahead and try to use those properties we've just discussed with your table to try and identify that. Again, keeping in mind, the second time I did it, there was no streak at all. It didn't rub anything off. This one has the lines in it too. Kind of looks like it's got a flat surface to it as well. So perhaps it has some cleavage. You can see that when it broke along like flat planes to a certain extent. It's probably not the best sample. So see if you can figure out what these two are based on the hardness test we did, right? This one, a little bit harder. I couldn't scratch it with my nail at all. This one I could get with my nail. So the Mohs hardness tells us that it's 2. I could get it with my nail. That tells us it's a 2. And then this one not at all, so that's a little bit harder. So try and find a couple on there that you could actually use to identify. This also seems to have broken on a flat surface this way and a flat surface this way. So I think that's probably a hint as well, right? So you could look at the cleavage. Use any other things on your table that help you to identify it, and go ahead and fill that in, and don't forget to fill in the name, mineral name, and a common use for it, whether you use it off the table in that other properties area or look it up online. Okay, so we've got those out of the way. Hopefully. If you haven't, you can go ahead and contact your teaching assistant via email, and I'm sure they would be more than happy to help you go ahead and fill out some more of the information, or help you identify the mineral if you haven't yet. So that gives us 6 minerals we've done. So now we're down to 7. So this one has a hardness of 6. So let's see what that means on our Mohs hardness scale. A hardness of 6. That means a steel knife or a nail does not scratch it easily, but it can scratch glass. And it contains a K on the periodic table. You guys remember what your periodic table, the K on there is? That's a pretty good hint. So, and this one is under non-metallic darker. Well, if we look at these, we said all of these were light. We said we didn't know about this one. And we said that this was dark. So let's see. This is our dark one. Let's see how hard this is. So I'll take my nail. Nail scratches it pretty easy. Would that be a hardness of 6? Look back at your Mohs hardness scale. Alright, so I think if a 2 is the fingernail, this probably is not it, right? So let's see about this one. A hardness of 6. So steel nail doesn't scratch it. And it doesn't really. But it'll scratch a glass plate. Wow. Yeah, that scratched into it pretty good. You can feel it with your fingernail. So it scratched the plate. So, look this one up on the table. You know that it's got a hardness that scratches scratches the glass plate, but a nail won't scratch it, so that tells you it is above a 6. What other identifying factors could you use for this one? Based on the shape? Maybe the color? So take a good look at it and find 2 other identifying characteristics that could help you with what this one is. Alright, and then we've got non-metallic darker, one-directional cleavage. So, that means it's one direction, right? This actually flakes off in thin sheets. Think of any other identifying features? We already looked at one in the last, helping to identify the last mineral, helping to narrow it down. Are there any other things you can think? Look at your table and go ahead and fill out your assignment with properties that you would use to help identify this. Okay, hey, page 1's done. So now we're on to page 2. Now your hint is this is the hardest common mineral. So let's look at the most hardness scale. Well, if you start at the bottom, diamond is a 10. But that's not really common, is it? So if you go up to the common one, you'll see what it is. Now, how are you going to pick that out? Well, if it's the hardest common mineral, you know it's going to scratch glass, right? Because it's super hard. So let's see. Does this one scratch glass? No, not so much. I wouldn't say it's scratching it. It's just rubbing off on it. Oh, that one felt like it did something. Better keep that one out. Oh, this one's so soft. No, it just slides along it. Again, just slides along it. Slides along it. Oh my goodness, that one scratched it really good. I feel it with my nail again. Alright, so we're down to 2. What are some properties that can help us narrow this down? Well, read on your table and see if you can find something that would help you determine between the 2 of these which one is which. So we've tried hardness. We know that both of them will scratch glass. So let's try another, help to try and narrow down the hardness of these 2. So let me see. Well, I know my fingernail won't do it. Not on either one. If they can scratch glass, there's no way, right? You know the penny won't do it if it can scratch glass. Let's try a nail. Oh, it did scratch it a little bit. Not much, though. Try this one. Oh, I can't get this to scratch it at all. Not even making marks on it. So that's going to tell me this one's a little bit harder than what this one is. They're both pretty hard though, right? Let's see. Go back to your table and see if you can find some other properties that might help you differentiate between the two of those. Color difference, right? You might have some color differences. Is there a shape maybe that could help you? They're shaped very different. Go ahead and look at those two and try to identify them using the table that you have, the things that we've done, and see if you can determine what they are. Again, if you need help, you can always contact your TA. Wow, look at that. These two look very similar, don't they? That might be a hint as well. You can always reference other minerals. Actually, that's what the Mohs hardness scale does, is reference other minerals and common items. Alright, so I think we're probably down to these ones now, right? So what's the next one on your table? Well, we have one that says it has a hardness of 2. So we know if it has a hardness of 2 that I can easily scratch it with my fingernail, right? So let's see what we've got here. Oop, yeah, look at that. Easily scratches with my fingernail. Not so easily. So we're gonna, it scratches, but not so easily. This one I'm not really getting anywhere. I think it's taking my fingernail off. Nope. Whoa. This one's like super smooth and soft, and I'm making a big old gouge in it. Alright, so those are probably our softest ones, right? Looking at their colors, does that help us with any identification? What do you think? Reference your table that's filled out. This one's very soft, and you can see it's rubbing off in my hands. Is there a substance that you know of that kind of reminds you of that? Something you're familiar with, perhaps? It's got kind of a silky feel to it. It's kind of light. Yeah, it's a little bit lighter than this. This one has kind of neat things in it too. And you see those lines? This one doesn't have that at all. Try and use the properties that you see to differentiate between these two minerals and give them a name. Use the table, and again, if you need to use your teaching assistant for the semester, you can always call them. This one it's still scratched with my fingernail, but if you look at it, it's quite different than those, right? It's got sheets again. It's pretty clear color, very light. think I tried to streak it. And the streak is either, well, could be a white streak. Did we streak these? Ooh, that's a nice white streak, huh? There's a white streak. Okay, so try to differentiate based on the appearance. The lines that you see in this one, you can almost see those needle-like. I'm hoping this is turning out in the video. So try to identify those. And that should bring you down to just 2 left on your sheet. One says a parallelogram-like shape. That's a pretty good hint, isn't it? The other says 3 cleavage at 90 degrees. Well, those are pretty good hints, right? But what other things can you use? The colors are very similar. So you need to think of other properties that you could use. So let's go ahead and try to find some other properties that can help you differentiate between those two. So if you look back at your table, let's see. Well, these are colorless, right? So you've got some on there that are colorless. Most of them are already taken though, right? So surely there are only 2 that are left. So we tried the fingernail. It was kind of hard to do on both of them. So let's try the penny. Yep, that gets it. Yep, that gets it too. Alright, well, we know they've got a similar hardness to each other, right? Because the penny will do it, but my fingernail doesn't really. So it's got to be more than a 2. Which I guess at the 2 that you have, that really doesn't help that much, right? One says forms cubic crystals. And on the other sheet, the one said that it had a parallelogram shape. So that's going to help you, right? Also, reading some of these other properties, it says one of these perhaps fizzes in dilute acid, in hydrochloric acid. Now, if you were here and you felt like it, which I wouldn't recommend, especially since all these kits have been used so many times, you could lick them, because one of them is supposed to taste salty. I'm not going to lick it, because you wouldn't be able to taste it anyway. But what I will do is put a drop of acid on each one, because one of them is supposed to react and the other will not. So let's see. Now when it reacts with acid, what's happening is it's releasing carbon dioxide. So think about a soda pop. What's in it? Carbon dioxide. So we should expect to see bubbles. So let's see. Well, I don't see any bubbles on this one. But I sure did on that one. And it's still bubbling a little bit while the acid continues to react. So, that should give you your answer for those 2. And at least another property that you can put in the 2 properties for identification. Alright, that concludes your mineral identification. I'm going to go ahead and take the video camera and we're going to go up to Rood Hall on Western Michigan University's campus and visit the museum there so we can see some of the better quality minerals that Western actually has. And you'll have a questionnaire for that as well. So hello again, and welcome to Western Michigan University's campus. This is the Rood Hall Department of Geosciences and the Schmaltz Geology Museum. It's kind of been a stormy, windy day out here, so luckily for me, there's only one thing we really have to look out outside. So I'm walking up to it now. This is a large chunk of native copper. Hopefully you can see it. It's starting to rain again, so I'll try and make this quick. You're going to want to read this because it's going to help you answer one of the questions on page 8. So I'll try and scan through this as close as I can so you can go ahead and be able to read it. Alright, well hopefully you got to read it because it's raining again, so I'm heading. Alright, so now we're entering the hallway into the Schmaltz Museum. And on our left here is a large mastodon display. So I will try and get close so you can go ahead and do the reading that is required here. But you can see the mastodon jaw and teeth. This was actually discovered locally, and some of the professors at the time at Western helped to excavate it. So let me get in here so you can read about it. Okay. Alright, so there's another native copper display in there. So let's go ahead and head into the museum. It's kind of a square shape with a center display. So there's a wide variety. We talked a little bit about cleavage. There's a display about cleavage. I didn't really talk too much about fracture, but there's a display about fracture. We did talk about luster. Remember I talked about color, that sometimes color can actually, it's not a good way to determine what mineral it is. So let's read on this just a little bit here. And it's an obvious attribute, but again, it's probably not the most useful. So we got that there. We got some very large crystals down here. It's a large sample of fluorite. There's a large cluster of quartz crystals. We had looked at the quartz crystals when we were doing identification. It's a large sample of calcite. We had also looked at some calcite during our mineral identification. We talked about streak. So streak is the mineral in a powdered form. Here, take a look again at the color. I believe you have a question on this, so I'll try to get so you can see the mineral names. There's sulfur. There's fluorite. A couple different samples there, huh? Rhodochrosite. Garnet. And we talked about hardness, right? So this one shows us hardness. We know that quartz is very hard. That's that one in the back there. There's graphite, which would be very soft. Gypsum. So there's a mineral in here that actually has a hardness of 9, which is pretty darn hard, right? What was our quartz again? I think that was a 7. Gypsum, of course, had a hardness of 2. Remember, we could scratch it with our nail. Graphite has a hardness of 1. Quartz, again, was a 7. So I believe you have a question on your sheets regarding that. So these are some native oxides. Go in and see them a little closer here. We have sulfur. I always liked hematite. That's hematite there. The looks kind of bubbly on top. Yeah, I always thought that was cool. Actually, I did one of my first reports on that. So Western has a lot of really neat mineral samples, some very large samples as well. Of course, our diamond is a little small, but hey, at least we've got a diamond, right? And you know copper has gone up exponentially in price, so well, there's some magnetite. You should be familiar with that from identification. So lots of different minerals in here. We'll head around and go look at some of the fluorescent ones in a second here. Interestingly, that is also hematite. So remember we looked at kind of the bubbly one? Well, it's just another form of it. But again, internally, its structure is going to remain the same, even though on the outside it looks a little different, right? So these are sulfates and sulfides. I always like the barite roses too, those are kind of neat. See, this one next to it is barite as well, but it's white. Again, color is not a great diagnostic tool when trying to identify minerals, right? There's some calcite in the crystal form. And these are carbonates and halides. I always like malachite. That's kind of a neat color, huh? Pretty amazing what Mother Nature produces. And again, none of these are handmade. They just grow like this in nature under the right conditions with the right ingredients. It's pretty neat. Another calcite. There's a big old massive group of calcite crystals there. Now we're on to the silicates. And you remember what we said about silicates, right? One of the most abundant minerals on Earth. missed something. Let's go back here. So, sorry about this. You see this? This is calcite. And this is a clear piece of calcite. And behind it is written one word with single letters. But do you notice what kind of vision you get looking through it? And if you read the tag, the bottom of the tag will probably answer the question on your sheet. All right. So moving on. Okay, so again, there's a lot of silicates, right? So we got a whole bunch of them over here as well. So let's see what this one is. Some rose quartz. Try and zoom in so you can see this one. Citrine. Quartz has a lot of different varieties. This one's known as a tiger eye. Those are polished. They're really, really pretty, and they use them as gemstones. This one back here is kind of grayish, and that's a smoky quartz. And this one's kind of interesting. It's another form of quartz, but it's enclosing rutile. So those things that look like cracks in it or feathers in it, yeah, that's another mineral that's encompassed in it. Another form of quartz there in the back. It's from India, very pretty green. Here's an agate, quartz agate here in the front. This one's called the Agate Thunder Eye. Now the agates form in layers, like you saw in that last one. Let's see that center part. I think that's why they call it a thunder eye, because it's just one mass in the center, rather than like this one. See all the different layers? And then you're probably familiar with these. I know if you've ever been to a rock and mineral show, they sell a lot of things called geodes. And when you break them open, you can sometimes find quartz crystals inside of them. So we've got one of those there. And then they sell a lot of the polished. That's a polished agate with quartz there. All right, so let's move along here. Just here are rocks that transmit light. So we can push to eliminate the samples and they'll glow. Pretty neat, huh? Very pretty. All right, let's go over here, and this is our fluorescent display. So if you look in the display cabinet, oh, you can see my shirt and see me. If you look in the display cabinet, it's pretty dark in there right now. When I push the ultraviolet light, you can see that the oil glows blue. You can see the blue glow there of the fluorite. Scapolite is glowing yellow right now. You've got some willemite that is glowing green. Let's see when the light goes out, no green glow, no yellow glow, no blue glow from a fluorite, and no glow at all from. So in here, you, like I said, you've got, let me see if I can zoom in so you can see how to spell it. The willemite, that one was glowing light green. Andersonite. Scapolite. Of course, fluorite, that's pretty well known, is really what it's called. It's not really glowing. There's travertine. Interestingly enough, people who discover minerals can name them after themselves or after their professors or whomever they like. So that's kind of neat. I just wanted to discover a mineral. It hasn't happened yet. All right, so there's the fauna. We have some fossils. These are invertebrate fossils. It's kind of a map of the timeline in a different way so that we can see the different epochs and eons and periods, and we can see what critters were formed when. So let's take a look at what's in here. Lots of little shell creatures. I don't know if you're familiar with Michigan, but in Michigan, our state stone is actually the Petoskey stone. And the Petoskey stone is actually a coral. You think it'd be our state fossil, but it's not. Our state fossil is actually the mastodon. And the Petoskey stone was actually a colonial coral, which means it lived in large colonies. And you can see these are the polished ones, polished Petoskey stone. There's the Petoskey stone. There we go. So you can see the forms inside the stone. They're pretty neat, huh? And then when they're not polished, that's what they look like. Alright, so let's take a look at some more of these shells. These are mollusks. These over here, these little critters are trilobites. There are many different forms of them for a very long period of time within geologic history. Lots of fun little things in here. Lots of stuff to read. I myself am not the greatest paleontologist, so you gotta bear with me on this. These are crinoids from the Mississippian. Let me back up here so you can see how massive that chunk of rock is. That's a pretty good sized chunk of rock with a whole lot of fossils right down in it. Pretty cool, huh? They're all broken up and turned over and stuff, so probably more of a debris bed. And then that's another big chunk. See all the fossils in there? Crazy. Lots and lots of them. It's like a massive shell bed. Here's one next to it. Again, you can see a whole lot of critters. These are all snails in there. A whole lot of them. There's a couple trilobites and a piece of stone there. Very successful critters for a long time. Alright. Look at this thing. I might have to back up to get the whole thing in. Pretty big, huh? Really don't have anything to give you for scale, but I'm telling you, it's big. And that's an ammonite. We've got a lot of these little fishes that were preserved in sandstone. I came in here and looked around before I applied for my graduate program and decided I was very impressed with the museum. So even during the time that I went to school here, I came back and go through the museum periodically. There's some more hematite. Love that stuff. I don't know why, but I do. Alright, so let's go ahead and walk around some more. There's lots more to see.
I have some of the other added things that I did download, but that one.
So this again is the copper display.
Yeah, let me
and what happens sometimes is people who collect really sweet minerals and very unique ones, very expensive ones, will many times donate them or at least lend them to museums so that other people can actually enjoy them and look at them. So some of these are very unique, very interesting. I've always been kind of a rock hound. I guess that's why I'm a geologist. This stuff is very intricate. I bought a piece of this once at a show, and it's very, very, very delicate. You have to be careful transporting that. You break the little fins off really easy. That's gypsum crystals. So gypsum, again, has lots of different forms. This one's kind of interesting. This is calcite again, but it's got a coating of limonite. It's pretty interesting. Got some malachite there in the back with the pretty green. You guys remember something that kind of looked like that? Those thin sheets for my identification. All right. Quartz right there. Right over here. So there's topaz and tourmaline. mind. Some more fluorite, just a different color. And there's fluorite that's more of a green color. Amazonite, smoky quartz. Quite a bit of it, I might add. There's another piece of fluorite in the back, kind of a purple color. So lots of interesting shapes and forms. There's some gold from California. Let's check out the next one. Michigan bedrock. I'll zoom out, you can see it better. You can see that Michigan's shaped kind of like a basin. So the center is the deepest, and then it's shallowing outward. And that guy was Michigan's first state geologist, 1837 to 1845. A short-lived career, if you ask me, but okay, so in here, that big sheet in the back, remember gypsum comes in a lot of different shapes and sizes. So there's gypsum from Grand Rapids, which is pretty close to me, us here at Western. There's some salt. This is from Berry County. It's actually one of the largest salt mines in the world is here in Michigan beneath the city of Detroit. Pretty interesting stuff. Because we used to be a shallow inland sea, so as the water evaporated, it deposited the salt. And that happened over and over and over until eventually we had quite a lot of salts. Some native copper again. Michigan is known for that, especially around the Keweenaw Peninsula. Also got a lot of BIF or banded iron formations. Got some really nice ones outside, but like I said, it's raining out there, so we're going to stay inside primarily. That's a banded iron formation. You can see all the bands in it. There's my hematite, but this is hematite schist. Interestingly enough, I had a sample of it in my bag, and it looked like a bag of glitter exploded in it. That was a lot of fun. Getting that out, it still hasn't completely happened, I don't think. So yeah, there's lots more native copper in there. Alright, moving on. So this is showing plate tectonics. You guys are going to explore that a lot more in future chapters and units, I'm sure. Oh, I think I probably should have showed you this too. The hematite schist. Please take note of where that's from. Now, hematite is an iron mineral. It's an iron ore. And we have that too. And that banded iron I showed you in back, same thing. It's from the Lake Superior region. So we had a lot of iron, a lot of metals, irons, coppers, and also salt. And gypsum. Got a lot of really nice Michigan mineral deposits. Alright. So, there's a lot of common rocks that are shown here. I want you to take a look at this top shelf here. Hopefully you can read that. Let's see if I can get any closer here. And we're going to learn more about rocks as soon as you're done with this mineral lab. Your next lab is going to be all rocks. And minerals are actually, we've discussed this before, are the building blocks for rocks. That's some rhyolite. granite. Some andesite. Diorite. Salt. Small crystals, very dark. There's some gabbro, which is also very dark, but it has larger crystals. We already looked at the diorite and granite. Now we've got some metamorphic rocks on the second shelf here. Again, we'll go through all of these when we go through our lab. And then we have sedimentary rocks on the bottom. And we'll take a look at a variety of different rocks in this next lab. That's his last display here, and then I think we can look at a few other things and call it. I think your question in this one is asking you to look for purple minerals in this game, if you can see these very well. That's your fluorite. Purple fluorite. Purple quartz. Here's a fluorite as well. That one's from Spain. It's got a very light purple hue to it. There's another purple fluorite. Probably doesn't look real purple in this light. That's more quartz there. And this is quartz here. This is amethyst quartz. Let's see how the quartz crystals kind of come to a point. So again, these are your purple quartz. The shape of that. That's a typical shape of a quartz crystal when it's had time to grow.
Sorry, you're suggesting that I actually go to...
And then for the fluorite, that is a typical shape. And those are kind of intertwined, but you can tell what the shape is, I think. We'll move over here. There's some more fluorite. There's lots of it in here. There's a nice sample. That one shows you a good shape of it. There's some more up there. So what shape are those purple lumps? There's another one here. There you are. So, let's see. So we talked about cubic, right, when we were identifying the minerals? So let's look around and see what else we've got in here that might be cubic. Well, there's another fluorite sample. That's pretty square looking, isn't it? What else have we got in here that looks cubic? Look into here. Oh. How about this here? You remember this galena from our lab? Gray, silver, metallic luster. Our sample wasn't nearly this nice, but look at that one. Remember that fool's gold? Ours had little tiny crystals like that, right? That's pyrite from Spain. A little bit of fool's gold. What else might have a cubic structure, you think? That's pretty cubic. I think we already talked about that one, right? Some fluorite. There's a huge piece of galena in here. You can see the cubes. See all the cubes there? And galena was an iron or a lead. Ore of lead. Alright. So let's go ahead and head toward the Napa. We have reached it. This display. If I can zoom out far enough to get it, I can't. I'm at the edge of the hallway and I still can't get the display. These are all fossilized shark teeth. Crazy, huh? There's a lot of them. We'll take a closer look. So this is a great white shark here. That's about the size of a diver right there. And that is the size of a megalodon, which was a big shark. Big shark. I think you have a question in there about how long one can grow, so let's read this first thing here. It says great white shark, a meek goldfish. Yeah, compared to that dude, huh? That's right. The largest shark to ever swim the world's oceans. Crazy, huh? Largest predator, land or sea. 2 or 3 times bigger than the great white. Crazy. Look at some of these teeth in here. That's intense. Let me back this up so you can see the size of some of these shark teeth. Those are some serious teeth. And this one here, it's just in stone, that's why it's so big, but it's just a small tooth. As compared to these guys on the bottom that are like megalodon teeth. Alright, let's see if we can find a great white in here. There's our modern shark. Yeah, that's pretty small. Alright, I think we have to go see a map yet.
Me too.
That's the modern shark. Not very large at all. Alright, so we've got one more thing on your list that we need to tour. And the last thing is right around the corner here. Okay, so this is a picture of Lake Michigan, which is the lake that is closest to me and us here in Kalamazoo. So if you look at the colors, they tell you how deep it is. And then you look at the scale here. Actually, if I can get you in close enough so you can read. Depth in meters. So then when you look over here,
We've got a lot.
I can send you a sheet to go in there.
see if I can find them.
I do have somebody I can send to.
You want me to fill out like a timesheet or like?
Yeah, or just keep track of your hours.
I've
Tell
been
me how many.
keeping track.
Okay, so
I've got a little.
that was the deepest spot that I saw.
Voice people, so I can give that to you and just fill it out.
All right, I'll email it to you once I'm done.
Alright,
Getting stuff
so
done.
there's the map.
I will have to make.
And that's Lake Michigan. That's one of the Great Lakes that borders Michigan here. And again, it's the closest one to Western. Alright, well that concludes our tour. Ended with a view of our great state of Michigan.
You wanted to run stuff.
And you'll probably hear from me again during the next lab.
But that anything you wanted to
Get ready for a rock lab.